That's
All right.
OBKB.
Get it? OBKB?
Yeah.
Where's KD?
KD, A, B,
What's my
C.
filter?
All right, anyway. Okay. Now, this guy here is a base. And so you might have been confused when you got to a guy like this. Ammonia doesn't react the way most bases do. Most bases just dissolve in water and give you, like sodium hydroxide, gives you sodium plus hydroxide, okay? But that's a strong base anyway, so another reason it wouldn't be the same. This guy reacts with water, and it's kind of weird, all right, because you're not expecting that about most bases. They just dissolve. So let's see what happens. You can figure out what happens with ammonia. We're going to write NH3 plus water. Now, oops, this is for H. Oh, yeah. All right, NH3 plus water. Now, if it were an acid, this is what you might have thought if you didn't know this. You would have thought, okay, well, he's got 3 H's, he's going to donate them, and you're going to get hydronium ions, but it's not an acid.
It's not.
Forms OH.
Yeah, how? How does it that it forms OH, even though there's no OH in NH3? What does the NH3 do in this case? Yeah, it takes an H from the water, and it makes NH4. And what's left over if I lose an H out of water? OH, yeah. All right, so that's how you get hydroxide ions, even though ammonia didn't have any in them. Okay, so that's kind of, that might have confused you. There's a second thing that might have been a problem with it later when we get to the bottom. But let's just do the rest of the thing the way we should do it. ICE. ICU. Intensive care unit. That's where you guys are all sending me.
That's where we're going to send you after Saturday.
After Saturday night? I'll be there.
I do have to call the ambulance to pick them up off the stage.
Mm-hmm. All right. The initial concentration of the ammonia is 0.100 molar. I don't care about water because he's constant. It doesn't change. I have no ammonium ions, and I have no OH ions. That's a very good zero. Look at that. That's a really good zero.
That's
I
perfect.
wonder what the radius of that is.
Minus X.
It is pi day, Mr. Allen.
It is pi day. That's right.
So we should
Actually,
yeah, Einstein's birthday, not pi day.
Either way. All right, 0.100 minus X, X, and X. This is the same way we're going to solve it as if it was a Ka problem, only it's going to be Kb. So Kb equals, what's it going to equal? Same equation. I don't care what the equation is. It's going to be products over reactants, only we're leaving out water because it's Kb, not just Kc. So NH4 times OH over NH3. And I don't worry about water. I know Kb is 1.8 times 10 to the negative fifth. And that's going to equal X times X over 0.100 minus X. Good enough. Now, what's nice about this? Same logic as before with the simplifying assumption. I can ignore this X. Just ignore him. Just ignore me. That's what you do anyway.
maybe he'll disappear.
If I ignore that X, I get rid of him. The problem becomes, just cross-multiplying becomes X squared equals 0.1 times 1.8 to the negative fifth will be 1.80 times 10 to the negative 6. Because multiplying by 0.1 is going to make him one space smaller, right?
Yep.
And then X is going to be the square root of that, which is what?
0.0013.
Is that correct? 0.00133?
No.
3.4 or 3.3?
Should we get another one?
Is it 3? Yeah, well, you have 3 significant figures and everything, right?
4. Yeah.
Okay, now, that's X. Now, here's the second part that might have been a problem. At this point in the Ka problems, that's your hydronium ion concentration, and therefore you just plug that in to get your pH. Well, that's not the hydronium. That's the hydroxide. So guess what we have to do first? When there's trouble,
Call
KW.
KW.
They call DL form.
And like a good neighbor, KW is there.
It's not all.
All right, KW equals hydronium times hydroxide. And I'm looking for the hydronium, because I already have the hydroxide. So hydronium is going to equal KW over hydroxide. So it equals 1 times 10 to the negative 14th molar squared over 0.00134 molar. Is that correct? That look good to everybody?
Yep.
And
7
what's your hydronium?
7.46 times 10 to the negative 12.
Everybody else get 7.46 times 10 to the negative 12? Y'all got that?
We
Okay.
all got it.
We're almost done.
7.46.
7.46.
Is that right? Somebody else should do that. Double check.
That's right.
All right.
That's right.
Jesse, did you do that? No. Come on. pH is going to equal what? Negative log of the hydronium
Yes.
or the negative log of 7.46 times 10 to the negative 12, right? What do you get for your pH?
11.12.
Now, that should not surprise us. We're getting a 11.12, or 11.1 basically, for a pH for a base. That's what you'd expect, right? You'd expect to get that. Now,
Especially with a weak base.
you expect to get something above, 7. Now, I'm still not done. I got percent ionization. Again, a little reminder of how to do percent ionization. Again, part over the whole, okay? Part over the whole times 100. So it's basically, your part is, whatever that got, 0.00134 over 0.100 times 100. What do you get for your percent ionization?
1.34.
Yeah. Sure?
Yeah. Yeah.
Okay, 1.34. Okay.
Question.
I'm trying to remember last periods, but that wouldn't be the same because I did change the numbers. Okay. All right. Is everybody good with that?
Yeah.
All right. Let me pause this. You guys